Hello viewers, in this video we will learn how to calculate hydraulic capacity of a pipe using hydraulic toolbox. This is Zara from Civil Engineering with Zara. So today we will discuss use of hydraulic toolbox. So first we will need hydraulic toolbox. So just go to Google and hydraulic toolbox. So Federal Highway Administration hydraulic toolbox. Here we will see hydraulic toolbox version 5.2, which is the latest one, and this is free of cost. So you can download from here and then install on your system. So I have the already downloaded and installed. So I will be showing you how this looks like. So this is the program. File menu, display calculators, profile units. There are 12 calculators, so we will use the first calculator, new channel analysis. So for this use, I have developed four scenarios. First scenario, pipe flowing less than half full. In second scenario, pipe flowing full. Third scenario, pipe flowing more than half full. And fourth scenario, pipe flowing full. So all our pipes are 12-inch diameter and 1% slope and Mannings, and I will be using 0.013. So let's start with this program. So this is so there are few cross sections like trapezoidal, rectangular, triangular, circular. We will be using circular cross section. Circular cross section. So pipe dia is 1 foot. Longitudinal slope is 1%, 0.01 foot per foot. Mannings n is 0.013, and we will enter depth because flowing depth is 0.25, 25% full. 0.25, calculate. So flow capacity is 0.488 CFS, cubic feet per second, for depth 0.25. And here are some output parameters like area flow, weighted parameters, hydraulic radius, average velocity, top width, Froude number, critical depth, critical velocity, critical slope, critical top width, maximum shear stress, and average shear stress. So in case number two, again is 1 foot dia pipe and 1% slope, but now I will be changing depth, which is 0.5 foot, half full. Now flow capacity is 1.781, depth is 0.5. So in our third case, we are using depth 0.95, 0.95% full, so 0.95 depth. So now flow is 3.28, and in fourth scenario is full. So we will enter depth 1 foot, calculate. Now flow is 3.563, and we can plot curve like this one, and we can compute curve like flow is y-axis depth and x-axis you can take any parameters like flow, area flow, and here you will get depth. This concludes today's video. We will be giving you more videos about hydraulic toolbox. Thanks for watching.